So today we will be going over, like you said, the how fiber providers are losing deals and how we can stop it with GIS solutions and advanced GIS solutions like 3GIS and others. But has there ever been a situation where maybe you knew the answer and you didn't quite get your hand up in time, or you were had only got partial credit because you just were oh so off, like a Jeopardy question or something? That's a pervasive problem we have found from market feedback from different users of 3GIS and other telecom operators, where they get bids, they have RFP, RFI potential, but they lose deals either to a few different reasons that we're going to go over today. But some folks already do rely on maps. They either can take their data and perform somewhat of a heat map to understand how far they can go out from a panel or a splice and say, hey, I can go about 20 miles this way or that way. It just totally depending. Other folks will use a network analysis tool from Esri to say, hey, how can I get there? But again, these are going to be, some mapping tools that don't exactly, take into account of your connectivity. And that's what we see a lot at 3GIS. We see, folks come to us with either really good telecom data, but they have no way to map it, or they have excellent GIS data and they don't know really what's connected to what, and they can't really, parse through that. And that's really what these advanced GIS solutions can offer, is a way to integrate both. So in this example, in my map with my integrated network that has my connectivity, I can set parameters to find an on-net route, or I can set a point at the top of the north there, and then a point at the southwest, and say, hey, how can I get from point A to point B? I can have user inputs. Hey, I don't want to go down this street. I want to avoid this fiber cable because it does maybe have utilization I want to avoid. A lot can be taken from that. You can also say, hey, I want to go more than just one. I want a 2-pair, 4-pair. How many other pair you want? It's going to be able to find that path. It can also suggest splicing. It's going to avoid circuits that are already taken, like I mentioned. So that splicing suggestions is definitely a big one. We've seen that can really help folks out because, again, not only is it going to bring you from A to Z, but it's absolutely going to, give you some suggestions so you're not just in the dark. And that kind of brings us to kind of how folks do it outside the network. Again, this is going to use some of your infrastructure. How can I jump from it to do a brand new route, brand new build, dig, or extension off my network? And so what some folks do, they'll use like a Google Maps or Amazon, Apple Maps, and say, hey, driving directions, take me from where I am to where I want to go. And again, that does help with that speed and efficiency. It's easy for anyone to access. It's free. You can log in at whenever you want. Really no downtime because it's such a big platform. But again, you're going to be using a cost of just a blanket cost per foot that you've probably calculated to get you somewhat close to that estimate. So it could be inaccurate. And then when it comes to driving directions, like we see right here, it's always going to want to find you the shortest route, which, as we all know, may not be the best. Could be going over bridges, interstates, going into protected lands or HOAs, whatever it may be, that after the end of the day, when you actually go to really scope it, it's going to really drive your prices. Another way folks do it is with manual design. This is what we hear a lot that users and engineers will do, where they just take the time to say, I want to start from this splice closure and work my way 5-10 miles to serve this customer. This is by far, I would say, one of the more accurate ways to do it. You're going to understand, again, how much it's going to cost, probably very low risk of rescoping, but that time investment could become an issue because once you fully understand, what it's going to cost, where it's going to go, you're going to realize that it might not be viable for your provider. So you've wasted all, not waste, but you've used a lot of that time resource to to not have an end result. And again, that route analysis might just be siloed to that one site. So there's no possibility of daisy chaining maybe, or using other contexts of like, hey, am I going to pass any other buildings? Nothing like that can be done. So a couple of issues there. So how can we solve that? At 3GIS, and I know a few other places, we can use a routing tool that allows you to use street data, but it's going to find you the least cost route to it. It's going to allow you to run it on your integrated network. You're going to be able to run as many demand points as you probably want, or just at an individual basis. And of course, you're going to have to be able to update it on the fly. So customizing that is very, very important. Right here, you see you can actually choose which part of your infrastructure you're coming out of. Do you just want to utilize your splice closures, maybe your structures or poles? Do you want to avoid equipment? All that can be easily chosen on a use case per basis. So what does that look like in the end result? Is it's going to be a very quick analysis. If you run 200 to 300 to 400, whatever it may be, you're going to get all of those back, in a much quicker time than you would have previously. Since it's being run inside of your integrated network already, you can easily import that data into your integrated network to start a low or a high level or low level design. You can export that route to maybe another part of the business that wants to approve that route and make sure it makes sense. And you're going to be able to focus on other potential. You can see the businesses that it passes that might need service in the future. So it's not siloed to one route. So again, very quick and efficient is the name of the game here.